A rat's nest of wires in your robot isn't just an eyesore, it's a prime cause of frustrating problems that can bring your entire project to a grinding halt. But getting your wiring right isn't secret knowledge passed down through the ages. It's a learnable skill that will make your robots far more reliable, much easier to troubleshoot, and ultimately more successful. I'm Brogan Pratt, and with over 10 years as a robotics design and technology educator, I've seen firsthand just how critical clean and organizing wire is for any project to truly shine. So in this video, I'm going to show you the essential tools you'll need, cover proven techniques, and share a bunch of practical tips and tricks. Then I'll walk you through step by step how I cable manage one of my own robots, so you can see exactly how to transform that wiring chaos into a clean, functional, and practical setup. Let's talk about some of the common tools. Find that some needle nose pliers really help. A pair of flush cutters or wire cutters. These come in various sizes, but something that has a nice flush end works quite well. Some sort of tape. Of course, a pen is useful. As far as securing tools you need, I'm a huge fan of Velcro. You can get in these larger rolls or these small little tie-down sections. And of course, your common zap strap or your cable tie. These come in lots of different flavors, sizes, and lengths. Having a few different really makes your life a lot easier. Lastly, in terms of some cable protection, some sort of Y splitters you likely will need. Some sort of servo extension cables with a servo female shroud on one side and a male on another. For these ones, I like to use this little 3D printed adapter. And what it lets you do is it allows you to connect your ends. And then you slide this over top. And it helps stop your servos from disconnecting because it holds it nice and secure in place. And then for my specific system, having something that protects us from our aluminum channel, protects those wires as we start passing things through. Now, before we go anywhere, having a pinout really helps. A pinout is effectively saying on your microcontroller, you have all your individual ports. For me, I'm only using the digital ports in this project. So I'm using digital 0 all the way through digital 13. And I have specific items listed. So for instance, this is my RC controller for these specific channels. For these specific channels here, there are my servos. And for these specific channels, there are my DC motors. And everything is labeled for where it needs to go and eventually correspond to. The reason we're going to do this is we're going to label all of our parts as we go. So if anything ever comes unplugged, we know exactly where it needs to go. So I have one of these pinouts in my engineering journal sitting beside me at all times while I'm working. Let's go ahead and take a look at the rat's nest of what it is we're going to be wiring up here. So I've got a mechanism chassis robot here. It has 4 DC motors connected to each individual wheel. I have 1 servo motor, 2 servo motors that help lift up my main lift arm. I have a 3rd servo motor that rotates my top claw. And then I have a 4th servo motor that actually plugs these things in. Now, this one is a bit of a challenge because not only does this claw point need to be able to eventually have power, it has to have a point where this cable can rotate around without snapping, and it needs to be able to rotate up and around on quite a large, so let me show you that better view, and it has to be able to also rotate this all the way around in a very wide arc. So that's quite a cable management conundrum that I'm going to give you some tips on. Everything comes back to our battery pack here. We've got our main power switch in an easily accessible area. I have 2 motor controllers, and then I have my microcontroller on the back of the robot. So the first thing to know about proper cable management is that everything starts with good layout of where your pieces are going to be. My battery's in an easily accessible place. It's tied down with some Velcro so that I can strap things out. Another battery here that's not controlling my microcontroller, this controls all of my motors, is another easily accessible place. It's tied down with some Velcro in here so that I can very easily take it in and out. My motor controllers are in convenient places for you to grab. They're nice and close to my power switch, as is my servo power controller here, my UBEC. For that, that's also an easily accessible place. That makes life a lot easier. Putting your electronics in a smart place to start is going to help you out a lot. So now it makes sense to start cable managing everything in a organized fashion. So on my chart here, I could really start with my servos. I could start with my DC motors. I've already done my RC channel down here. That's done with 1 single cable, which makes life a lot easier. One thing you can do that I've done is on my controller here, I need to have 6 separate cables coming off of this. So what I've done is I've actually taken an Ethernet cable and ran it through so that I can have all of these digital wires connected in a single sheath. And that makes life much, much simpler when it comes to wiring these things all together. So finding ways that you can combine wires makes your life a lot easier in the future. So let's start with doing our DC motors. So our DC motors, our drive motors, if we were to lift this up, look at the bottom, come from underneath our drive and they control the individual wheels respectively. I need to find a way to connect these back to one of these motor controllers. Each motor controller controls two respective motors. So what I'm doing is I'm controlling the two on this side is going to go to this one. The two down here are going to go to this motor controller. And that helps save some time by having things close to where it is they need to go. Now there's a few ways that I could route these cables. I could route them through this joint, through this point, and then back up. I could route them up through the top and back up. I could route them underneath here and then through this joint. You need to find a point that's going to be convenient for you and where your robot design is. Because I've got a main pillar coming up through here, I don't really have to route my cables through this section because there's no harm in me routing them up top here. And that honestly is the easiest connection. So what I'm going to do is I'm going to take these cables, I'm going to route them through the top. But before I do that, one of the biggest tips I can give you is labeling your connections for where it is they need to go. So on my robot, I've labeled my 4 individual wheels as front right, front left, and rear left. So these two are my front left and my rear left motors respectively. So we're going to grab our tape. You could also use a label maker for this. Label maker might make things a little bit prettier, but I've got access to tape right now. We're going to go ahead and we're going to label all of our motors. So I'm going to look at my pinout and I'm going to say, okay, the edge of my tape here, I'm going to say front right goes to D4. I have my rear right goes to D5. I have my front left to D6. And I have my rear left to D7. Now when I cut these, I want to cut nice and close to my letters here. I don't want to cut straight through, and I want to leave about half as much of the distance around. So let's go ahead and look at our robot here. This motor down here is our right front robot. So our front right. So I'm going to go ahead and peel this off. And what I'm going to do is I'm going to grab our motor from my connection. I'm going to find to where the ends go. And I'm going to add a little flag here. And I'm going to wrap it around halfway and attach it to itself. And what this lets me do is now I have a very convenient flag that knows where things need to go. I can go ahead and do the same thing on the other motor. So I've got my rear right. Again, I'm going to put it about halfway in, so I get a nice little flag. Kind of self-adhesives it to itself. It's not too big, and it's very clear for me to write what that is. This is my front left motor next. Now, this might seem a little bit excessive to do. But here's why I suggest you do it. You're not going to be doing your motors up very frequently. But what you are going to be doing throughout the season and throughout your building of a robot is you're going to be constantly changing servos and things like that and changing ports, unplugging things, replugging things in to be able to test them. And it is a gigantic time waster to have to go back and re-look at your pinout every single time, figuring out where do these cables come from. You don't know anymore. So by doing this, it really helps to save you some time. So now I could have routed these things through here, but I'm actually routing them up through the top. Now with my specific pattern here, I'm building a chassis off of GoBuilda, and you don't want to have wires around bare metal connections. This is a just sharp, quite sharp section of aluminum on the inside that I don't want to have things. So what I can do is GoBuilda sells these little pieces here, and this is just a little circle plastic protector that fits inside of those holes. So I can go ahead and push this in from the top, and now I can feed my cables through. So I'm going to go ahead and feed these through one at a time. grab it with my fingers on the far side, grab that other section, feed it through, and go ahead and pull that all the way through. And I can go ahead and do the same thing on this side. So I can go ahead and put one through. And you're going to find you can only get so many cables through one of these grommet holes. But I find that encoders and 4 of them work just fine. Now, at this point, I'm going to go ahead and do the bottom one, but I'm not going to pull it through all the way again. I'm going to go ahead and take my little protector again. I'm going to push it through our hole from the bottom. And we'll go ahead and feed our DC motors through again. Really helps if you're constantly changing your angle here to be able to get through and feed things. I'll do our last motor through. Now there's a reason that I didn't pull these motors through super tight, and that reason has to do with something called cable strain. You do not want to be straining your cables. And when I talk about cable strain, this is what I'm talking about. So if I were to take this cable and I were to pull it super, super, super tight, I'm now straining this connection. Or like here, I'm now straining this connection, this motor. You're going to actually see someone in the past here has actually strained this connection. You can see that it's actually got pulled out or worn out a little bit. So what I want to do is I actually want to back these off a little bit so that they have a little bit of play for them to move with inside of this motor. I don't want to be pulling super, super tight, because then if there's any sort of strain in your cable, you could actually pull it out of those sensitive electronics. And that is a recipe for disaster. So let's go ahead and flip our robot around, and we'll take a look at our main point here. So we've got our points over here. And now in order to avoid that cable strain, I'm going to constrain these points here near their connection point. And to do that, I'm going to use a small little cable tie. And with this small cable tie, or small zap strap, whatever you want to call them, or zip ties, some people call them, we need to find a way that we can get this through and up so that we can hold and constrain these motor cables down in their place so that they're not constantly tight on them. Now, getting them through these holes can be a right pain. So what I like to do is I like to grab the end of my cable tie. I like to bend it around and give it a quite hard push in there. And that gives me this kind of little J hook. Sometimes I'll even do another one. So I end up with a much more intense J. And now what I can do is I can actually scoop under, twist it up, and for the most part, this makes it way easier for me to get my other end of my system through. I might need to use my needle nose pliers to give it a little push. And now, I'm going to grab my needle nose pliers to help me out here. Now, that just made life way easier for me to be able to actually mount those through on that point. So now I'm going to go ahead and make sure that as I put these things down, I'm going to give them a little bit of that cable relief. Go ahead and tighten these down with a cable tie. Now, I like to kind of pull, wrench, pull, wrench, pull. And again, I'm not going crazy tight on these, but this is a nice little constraint there. Now I can go ahead and take my flush cutters and flush that out, and I've got a nice, strong connection off of that point. Let's go ahead and finish off this side of the motor, because now we have to actually connect it to our motor controller. And now you can see why having these things tied up makes life super, super simple. So I know when I look at my pinout here, this is the front left-hand side. My S1 should be going to my front left motor. And I know that on my motor controller, S1 corresponds to motor 1, which is this side over here. So I'm going to go ahead and grab my motor cable here, and I'm going to connect it to the front left motor, or FL. I'm also going to go ahead and write FL and M1 on this side so that I don't forget that. So let's go ahead and write that down. So I have FL, M1, and I have RL, M2. We'll go ahead and give those a little cut. When you're doing this, make sure your fingers are out of the way and not here, because it's really easy for you to pull down and slice through a finger. I'm going to go ahead and give these that little flag treatment again. And then same thing on this side. Oops. We'll give a flag treatment on this side. So that makes connecting these things nice and simple. So this is my front left. We'll find our, that's my rear left. We'll find our front left. And we'll go ahead and connect these in. Making sure, of course, you know, red to red, black to black, depending on how it is you're going to reverse these. On one of my side, because I'm doing mechanism drive, I'm actually going to reverse it on the other side, but that's okay. And now we, of course, we know the other one. Just double check. Rear left. Yep. Or sorry, right, left. We're good. Or sorry, rear left. Yep. Okay. And front left. So we've got those wired up. Now we can go ahead and actually cable manage these out of the way. Now when I cable manage these out of the way, I'm going to make sure that I'm not going underneath any other cables that might need to get in that way. Because as you're running those things around, that ends up being a bit of a disaster. So I'm going to go underneath my power cable here as opposed to going on top of my power cable. Just so that I'm making sure that I'm not getting in the way of anything. And now, where's your good friend Velcro? Comes in handy. I really like these strips, and we're going to find a place we can tie down onto. And for us, it looks like right beside the power switch will actually be a pretty nice tie-down connection. So I can go ahead and grab both of these, and I can kind of wrap them around each other and just kind of fold them up. Just kind of fold them up so that they get nice and out of the way. And we'll go ahead and we'll grab this Velcro strap. We should be able to pull that nice down and tight and get that pretty tidy out of the way of anything movable. Now for me, I might add another cable tie, or I might give it a little twist here and push them down so that they don't get anywhere close to this moving gear. That might be a bit of a recipe of a disaster. So that's this side done. Let's go ahead and repeat the same process on the other side. So again, I'm going to grab that small cable tie. We're going to get rid of that cable strain here. I can give that little fold tab again. That little J hook, that makes life really, really simple. And we're going to go ahead and find ourselves a little hole that we can work up through here. Sometimes shoving a finger up from underneath can help you get just enough clearance here, using some needle-nose pliers to help you grab those out. And on this one, I'm going to make sure I push them back a little bit so I'm not doing any cable straining. And then we'll go ahead and constrain this down near your connection. It's a really helpful thing to do, is to always constrain your motor wires down near a connection so that you don't have to worry about that cable strain. Now let's go ahead. We're going to use another good friend Velcro here. Actually, before we do our Velcro, we need to do our cable points on our motor controller again. So I'm now working on the right side. So we're working on the front right is M1 and rear right is M2. Give these a little sneak through. And we'll go ahead and connect these to our motor controller's cables. Now, if you're just directly connecting this to your motor controller, not a big deal. We'll go ahead and wrap the other one. Again, this is one of those things that just feels like it takes so much time to do. But by having a good system set up from the start, it makes your life so much easier. You don't have to worry about stress. Oh, actually, I need to reverse these cables because of how my mechanism drive is working. But it makes your life so much simpler to not have to worry about if something gets unplugged, or you need a test if a motor's working or not. If you took an impact on something with your robot, It feels like it's going to slow you down, but trust me, in the end, it's actually going to end up speeding you up. So we'll go ahead and grab our old friend Velcro here. I like to grab both of these and kind of wrap them together. And this is a good time for us to talk about not having too many cables in one place. You do not want to have 7 million connections or 7 million wires connected and tied up together. In my experience, 2 motors, maybe 3 motors is about the maximum that you should consider constraining to itself. I'm actually going to make that a little bit tighter. I did not like that connection. Is the maximum you should consider constraining to itself. Because if I need to change one of these motors and I have 4 or 5 motors wrapped up here, now I have to remove the connections of 4 to 5. So what's preferable instead is actually constrain individual motors together and then constrain those individual motors together into a larger clump. I know it feels like one of those things that takes a lot of time, but it will end up saving you in the future. So next thing, now that my motors are mostly out of the way here, I'm going to move some of my servo cables out of the way. And let's do our battery switch. So our battery switch is a pretty critical piece, and then I've got this main component here that I need to eventually power 2 motor controllers and a servo UBEC. So with my battery, thankfully, it's already in a pretty convenient spot where I can go ahead and mount that in like so. And I need to do 1 Y splitter for this. So one of these sides needs to go into my servo UBEC, and the other 2 need to get split out onto my motor controllers, respectively. Oops, that's backwards. There we go. And then onto my servo power. So here, it's just kind of sitting awkwardly out in the distance. So let's see, where could we... I'll probably constrain these ones down over here with the zip tie, because they're right near one of my power connections. So I might use a zap strap to pull this connection in so that I'm not straining the cables on the back of my power supply. Or, sorry, my main power switch, not my power supply. So they're free and out of the way. But honestly, these cables are not too bad with how they stand. It looks a little bit messy, but it's really not that big of an issue at this point because I have free access to just about everything that I need. I could probably take some of these and work their way out a little bit so that I could move my connection, say, somewhere else, like I could move my main battery connection here and just kind of twist them out of the way. Or I could even just use a piece of Velcro, again, to sort of hold these all in place just so that it makes it a little less messy. And you know what? I think I am going to use some Velcro in the end. There we go. So now I've got that pretty well constrained out of the way. I've got my power supplies. Nothing is straining on these individual cables. If I wanted to, I could also go ahead and grab another zap strap and constrain my cables to my motor mounts themselves so that I'm not straining at this point or have this actually attached down to some sort of solid piece. So maybe I could have it attached to the top of my battery like so, making sure that I'm not actually grabbing my battery mount on this one, but the mount that's on the switch side. And now I've got my main power source constrained to the chassis so that I don't have it flopping around. Let's go ahead and do our servo motors next. Now up here, I'm going to try, let's take a look at this unit here. So here, I've got a servo that's attached on the inside. It's right beside some moving parts. It's moving parts here, and on the inside, I've got moving parts up over here as well. So we got to think about where could I route this cable that this isn't going to get pinched? And for me, it looks like I can probably get it through this point here. But because I don't want to have cables on some sort of bare metal, I'm going to use another couple of those little plastic protectors. Sometimes you can grab some sort of screwdriver, push through from the other side to help you give a little bit of extra love to get your unit eventually curved to get through there. Now, just like we did before, I'm going to relieve some of that cable strain. So I got to think about where I'm going to be able to put my cable. And for me, I might route it down below it here. There we go. So that I don't have that cable strain. And there we go. Nothing strained on that. We can go ahead and cut the end of that piece off. And let's see, which servo is this? This is our virtual 4-bar left. So this ends up going to D2. So I'm going to go ahead and write down, this is my virtual 4-bar left. And this goes to D2. And I'm also going to do my virtual 4-bar right. That goes to D3. Let's go ahead and cut those two out. Nice little flag. And we'll go ahead and mount both of those servos at the same time. Give that a little flag. Now, when I'm doing this flag, being careful that I'm not going too close to the end of my connector. Because what can happen is, by having all of your flags, when they're really close together, you can actually end up causing some issues with all of your flags now producing some more issues because they're too close to each other. So we'll go ahead and put that one on there. And now I've got both my 4 bars connected. And because I know this one's going to D2, I can connect it right into that second channel. Nice and easy. Bingo bango. Done on that. Let's go ahead and do the next one as well. And this is a good amount of cable flex. I could probably think about keeping this out of the way so it doesn't run into this point here. So I might do a little bit of a loose constraint on that one once I put my other virtual 4-bar in as well. So let's go ahead and put that other virtual 4-bar in, put another little plastic protector in. This one's a lot easier for us to manage. Go ahead and slide it through. Now on this one, when we're looking at the back of this servo, we could have it route around and behind, but that's going to add some unnecessary extra distance to ours. So I'm actually going to wrap it up and around on this side so that I end up with no cable strain and it's a shorter run for me to do. If I hadn't have done that, I may have actually ended up needing a servo extension in the end, and I don't really want to have to put a servo extension on this cable because it reaches my servo power supply just fine. Now this one is a lot easier for me to reach through to get rid of that cable strain. It's not near as close. We'll go ahead and tighten that down. Give it another little snip. And because I know this one goes to D3, we can go ahead and connect it directly into our D3 side. Beautiful. And this one, actually, I'm not even going to bother attaching down because I don't have too much cable strain on that. So let's go ahead and just do a loose connection. This one, when I say a loose connection, what I'm doing is just grabbing a cable tie. I'm just loosely holding it on here because I don't want to introduce any cable strain, especially at the end of my connector. So I'm just kind of loosely putting it on so that I'm not putting any strain in my connection, but it's not going to run into my other systems anymore either. Now this next one here is probably the easiest. So I'm going to go ahead and grab my cable protector, run it through that little pinhole, go ahead and push that through. And we'll go ahead and relieve that cable strain on this point. Again, thinking intelligently about where that cable strain is going to go so that I'm not pulling too hard on that cable. You got to think about cable strain on both sides, both on the main connector side and on the motor side. Now, again, you don't want to tighten these up too tight because then you're going to run into some of those problems. Now, this is my coaxial servo. This is my D0. So I'm going to say coax D0 for my flag. I'll go ahead and put that on. Go ahead and flag that out. And this one going up to D0. And the last one is probably the most challenging, is this servo here. Because I just have so many degrees of motion. And for me, I like to start at the end point here. So what I do is I grab my mechanism and I move it through all of its endpoints. So for me, this is an endpoint here, so maybe I might grab this point and hold it like so. I'm going to rotate it around. I'm going to say, okay, so if I put it there, am I going to run into any sort of issues? And it looks like that amount of pinch is going to be perfect for getting rid of cable strain. But on this one, I'm actually going to want to constrain this in a couple points because I don't want this cable to get stuck behind this cable. So I know that when this rotates around, these points never extend past. So this is a great place for me to add in a little bit of cable relief on this section here. So I can grab in one zip tie, and I'm going to add in a bit of cable relief on the servo connection itself, right next to the servo motor. So now I've got something that's nice in place. I'm not going to have to worry about that losing its point there. And I can still rotate freely around without that running in or getting bunched up. So now I'm going to go to the furthest point in my system, which at this point is here. And I'm going to go ahead and mount this to my main system like so. So I'll grab one more cable tie. I'm going to give a little bit of distance to that cable. And we're going to go ahead and cable tie this one down like so. And now I'm going to test this through its system before I keep going. I'm going to look for anywhere it might pinch, especially on the back side here. Let's change that view angle so we can see things a little bit better. So now as I rotate my system, I'm looking for, is that cable capable of being pinched anywhere? And as I rotate it all the way around, we are not being pinched. On the top half of our system, we've got a good amount of flex here. And on the bottom half of our system, when we flex all the way around, that might be the one concerning point, is as we come down, we pinch in here. But realistically, there's no way we can get around that. So maybe I'd add some sort of protective piece on top of this so that if there's any chance that I'm actually going to rotate this around and I hit this pinch, I wouldn't want that to damage itself. So let's keep going on the rest of that arm. In order to bring this all the way back to my other arm here, we're going to have to add some sort of servo extension cable. And now is where that earlier servo extension cable came in handy. These come in many different lengths. You want to use the right length for the right job. So I'm going to go ahead and plug this servo connection in like so. And then I use one of these handy servo connectors to connect it like so. Now, if you're going to have lots of servos, let's say you have some sort of long arm, you got 3 motors on the end of here, you should probably label at each connection point. That makes your life so much easier in case you have to trace wires back. You could even do it on the connector itself or on that little protection point. And that's actually probably not a bad place for you to end up putting down a point here. So I'm going to go ahead and say this is the claw servo. So I'll just say claw. And my claw is D1. We'll do one more flag here. We'll say claw D1. We'll put it at the end of our extension cable. We'll go ahead and put that little flag around. And there we go. Now we know where these are going. So now I'm going to go ahead and take this point. And I don't want to stretch it too much. I'm going to bring it back just a little bit, like so, because as I bring this system around, it's never going to get any longer than where it's currently sitting at. So there's no point at which this gets any longer than this current system. So a cable tie works perfect, and there's no chance that that is going to get sucked in. So one little cable tie right in the middle, and I've got a pretty confident that that is in a good spot where I'm not going to be running into a pulley and a belt. But again, we're going to verify that this goes around as we'd expect, and it doesn't look like we're having much at all, any cable strain all the way through our entire system. Last thing, We know which digital port we're connecting to, so we'll connect up to our final digital port. And then I could probably go ahead and I could even route this through this point here if I wanted to do, just as another little soft cable connection point. Not necessary, but I probably could to make things a lot nicer. And that's it. That's my robot, all cable managed up, looking pretty good. I'd be pretty happy with that. It might not be the prettiest in this section, but it's easily manageable in that I don't really have cables that are running around other cables. Cables are safe. They're not near large sources of electrical noise like these motor controllers or the DC motors themselves, especially with things like sensors. I have lots of cable strain relief. I have things nicely labeled so that I know exactly where each individual component is going. So I hope you found that helpful with some of those tips and kind of a step-by-step process working through that. If you did, consider liking the video. It really does help this reach more people like you, and consider subscribing for more robotics tutorials, design tutorials, and so on. And best of luck on cable managing your robot.